Okay, section 6.1 deals with the law of sines. The law of sines works for any triangle. It does not have to be a right triangle. Up until now, we'd only dealt with right triangles. Law of sines, law of cosines will allow us to solve for triangles that are not right triangles. Capital letters are the vertices. The lowercase letters are the sides. So opposite angle A is side A, opposite angle B is side B, and opposite angle C is side C. The law of sine states that A over the sine of angle A equals B over the sine of angle B equals C over the sine of angle C. We use it to solve triangles like number 1 in the assignment. Number 1 is telling us that opposite angle C is side C, and it's 12. It also gives me angle A to be 42 degrees, and it gives me angle C to be 96 degrees. The triangles are not always drawn to scale. Usually they're going to give you 3 parts of the triangle. To solve the triangle, you have to give me all 6 parts. They're already giving me angle A to be 42 degrees. They're giving me angle C to be 96 degrees. And they're giving me side C to be 12. You'll notice in the law of sines that they'll always give us an angle and the side opposite, and then one other piece of information. So you'll notice here they give me angle C and side C. It might give you angle A and side A or angle B and side B, but in this case they give me angle C and side C. Now the total degrees in a triangle is 180. So I have 42 and 96. When you add these you get 8, I believe 138. If you subtract that from the total degrees in a triangle, that'll tell me what my remaining angle B is going to equal. So what is this? Is it 42 degrees, I believe. So at this point, I'm going to fill in for angle B. I'm going to put in 42 degrees. Hopefully these add up to 180. Now, to use the law of sines, I think I have to use C over sine of C. Why? Because that's the only side and angle that's given where I have both of them. So I recommend you use that one. And it doesn't matter if we let it equal A over sine A or B over sine B. I'll probably start with A over sine of A. And let's fill these in. Let's fill in all the information that we know. So far I know that side C is 12, so I fill it in. Angle C is 96 degrees. I do not know side A, so I'm going to leave that as a variable. I do know that angle A should be 42 degrees, I believe. When you have 2 fractions equal to each other, you could cross multiply. That would give me A times the sine of 96 degrees equaling 12 times the sine of 42 degrees. The opposite of multiplying is to divide, so that gives me 12 times the sine of 42 degrees divided by the sine of 96 degrees. When I punch it into my calculator, it's going to give me an approximation. Up until now, I used the equal sign. Now it's an approximately equal to. Let me punch this in my calculator and I'll be right back. Okay, I punched it into my calculator. I had to be in degree mode because all the angles are given in degree. So please make sure that your calculator is in degree mode. Once I punch that in, I think I get 8.07. The instructions say to round to the nearest tenth, so you might call that 8.1. So I'm going to call side A, I'm going to call that 8.1. Now I'm going to have to do the same thing, but I'm going to have to solve for side B. I recommend you use what's given. Since you're given both C and side C and angle C, I think I'd use that because if you're using using side A, that's an approximation. So I might use C over the sine of C, but this time do B over the sine of B. Okay, we'll fill in all the information just like we did on the previous one. So what do I know? I know that side C is 12. I know that angle C is 96 degrees. I do not know side B, so I leave that as a variable. But I do know angle B now would be 42 degrees. Again, cross multiplying when fractions are equal to each other. B times the sine of 96 degrees is equal to 12 times the sine of 42 degrees. Then opposite of multiplying would be to divide, so I have 12 times the sine of 42 degrees divided by the sine of 96 degrees. And I'll punch that in my calculator. Give me 1 second. Okay, I punched it into my calculator and I got 8.07 again. Rounded to the nearest tenth would be 8.1. So my answer for side B is going to also be 8.1. Now you might have noticed that because the base angles are equal, then the sides opposite them would be equal. It's called an isosceles triangle. So you'd have two sides that are congruent, but we did not know that going in.